So students, in the last class, what did we discuss in the last class? Anybody can remember all topics we discussed in the last class? Anybody recollect? Divergence, then gradient, okay, then curl of a vector, line integral, surface integral. Okay. Next is the divergence of the different fields. Okay. Then divergence of the different fields we will be studying. That is just one definition here I want to highlight about the volume integral. Volume integral is given by integral rho v dv, just as we integrated here the integral rho s ds with respect to a surface. Similarly, if we integrate the volume charge density, volume charge density, that is coulomb per meter cube with respect to volume. So meter cube and meter cube will cancel and we'll get the charge cube. Okay, that will give us the volume, that is the charge stored in the volume. Okay, that is one point I want to highlight, and then we'll continue with next one. We'll solve few examples here, students. Am I audible, students? You are able to listen to me?
Yes, sir.
Okay, fine. Take down this example, students. Determine the divergence of the following vector field and evaluate them at the specified points given. That is, vector A is given yz ax plus 4xy ay plus yz az at the point 1 comma minus 2 comma 3. The question is, determine the divergence of the following vector field and evaluate them at the specified points. You have to find out the divergence at the given point. The given vector is a bar is equal to yz ax plus 4xy ay plus y az, and you have to find out the divergence at the point 1 comma minus 2 comma 3. Okay, that is x is 1, y is minus 2, and z is 3. At these points coordinates x, y, and z, you have to find the value of the divergence. Note down the example quickly, question quickly. Note it down, students.
So 1 minute, sir.
Okay, okay, take your time. Now note down the question first. I'll explain the problem. We'll solve the problem. Question I'm asking, whether you've taken down the question. Take
Sir,
down.
I also told the question also, sir.
Okay, okay, take it, take it, take it. I hope you have taken, students.
Yes, sir.
Okay, right. Now, according to our definition of divergence, del dot A. What is del dot A? Let us see that divergence we have defined in the last class. Divergence is given by the formula. Divergence is del dot A. Here it is, this one. Del dot A or del dot F bar is dou Fx by dou X plus dou Fy by dou Y plus dou Fz by dou Z. That is our divergence of the given vector. Okay. Here we are having F bar, that is nothing but our A bar here. Okay. This is, we have considered F bar in our, when we were explaining the topic. Now we are considering the vector A bar. That is the only change. So divergence of the vector A is given by the formula dou Ax upon dou X plus dou Ay by dou Y plus the given vector dou Az by dou Z. Right? This is the divergence of the given vector del dot A. Remember, curl means it will be del cross A. Okay. Del dot A means it is always the dot product, means it is the divergence. Okay. So dou by dou X of Ax. What is the X component of Ax, students? Here the X component of the given vector is how much? Yes, please, anybody? What is the X component of the given vector? Yes, X component of given vector is what?
YZ.
YZ. Exactly, it is YZ, because here it is a unit vector Ax, correct? Here they have given the unit vector Ax, so it is Ax, X component with respect to unit vector Ax plus Y component with respect to unit vector Ay, and the Z component into the unit vector Az. Okay, hence the X component of the given vector is YZ. Okay, substitute that. Then dou by dou Y of Y component of the given vector. The Y component of the given vector is how much? 4xy. Am I right? 4xy. It is the Y component. Ay is a unit vector. Magnitude is 4xy. Substitute that. Plus 4xy plus dou by dou Z of Az. The magnitude of the Z component of the given vector A is, it is Y into Az. Az is unit vector, hence its magnitude is Y. Okay, substitute that. Dou by dou Z of Y. Now you have to differentiate. Differentiate YZ with respect to X. Differentiation of YZ with respect to X is, you are differentiating Y into Z with respect to X. Okay, there is no X term in this YZ. Okay, hence what will be its differentiation? There is no
Zero.
Sir.
0. Right, you are right. It is 0. YZ into 0. Okay, or it is 0 plus dou by dou Y of 4xy. Y term is there, 4xy. Okay, so 4x is constant, take it outside. Differentiation of Y with respect to Y is 1. Okay, so it is 4x into 1 is 4x plus dou by dou Z of Y. What is the differentiation of Y with respect to Z?
Zero.
0. Substitute that. So plus 0. Hence YZ into 0 plus 4x plus 0. This will be equal to simply 4x. This is 0. This is 4x. This is 0. If we add all these three, we will get 4x. Okay. Now del dot A at the point. Here they are asking to find the divergence at the given point 1 comma minus 2 comma 3. X is 1, Y is minus 2, and Z is 3. Let us substitute these coordinates 1, minus 2, and 3 in the equation for the divergence that we have got. That is del dot A is equal to 4x. Del dot A at the point 1 comma minus 2 comma 3 is given by del dot A is equal to 4 into x. What is x? X is how much? Value of x
One.
in the given
One.
1. Yes, excellent. 1 is x here, x is 1. Substitute that. Del dot 8.1 comma minus 2 comma 3, del dot A is equal to 4 into 1. X value is 1. Okay, this is our x, this is y, this is z. Okay, x comma y comma z. 4 into 1, that will be equal to 4. Therefore, divergence of the given vector A at the point 1 comma minus 2 comma 3 is 4. Okay, that means what, friends? Divergence is a, it is a scalar quantity. Del dot A is 4. It is a scalar quantity. Okay, this is regarding one example. This example is clear to everyone? Anybody not understood this example? Any doubts in this example? I hope it is clear to everyone, this example. Yes, please. Anybody is having any doubts in this example? Any questions, any doubts?
No, sir.
No, sir. Okay, okay, fine, fine. Okay. Let's move on to the second example. For a vector field A, show that del dot of del cross A is equal to 0. For a vector field A, show that del dot of del cross A is equal to 0. What is del dot of this? Dot product means it is a divergence, is it not? Next we are having del cross A. It is a curl. Curl. We have seen the last class. Curl of a vector here. This is our curl. Curl of a vector is given by del cross of the given vector. Curl of f bar. Correct? This del dot of del cross A means it is del dot means it is divergence. Del cross of given vector means it is curl. That is, the divergence of the curl of any vector field is 0. We have to show that divergence of the curl of any vector, it is always equal to 0. We have to prove it. Okay. For vector field A, show that del dot of del cross A is equal to 0, or divergence of the curl of any vector field is equal to 0. Take this statement, students. Note down the second example. Taken, students. Note down the problem statement. I hope you have noted down the statement, students. Note down the statement first, then we'll solve the example. Then you can simultaneously take it while we'll be solving it. I hope you have taken the statement.
Yes, sir.
Yes, sir.
Yes, sir.
Fine. Okay. Here, let us assume that A, the given vector A, is in Cartesian coordinates, because it becomes simple whenever you are considering the Cartesian coordinates to analyze, to simplify. Hence, we'll assume here that vector A is in Cartesian coordinates, given vector A. Then del is given by dou into unit vector Ax by dou x plus dou into unit vector Ay by dou y plus dou into unit vector Az by dou z, or del operator. Okay, that's not just now I highlighted there, del operator. Okay, del operator we have discussed in the previous class. This is our del. Okay, del is given by del operator. It's also called as vector operator. That is dou into Ax bar by dou x plus dou into Ay bar by dou y plus dou into Az bar by dou z. So we are assuming that del is this, then del dot del cross A. Del is this, dou Ax by dou x plus dou Ay by dou y. Please be taking, students, as I'm solving here. Note down in your notebooks parallelly. Okay, in between, if you have any difficulties, you can ask me. You can ask the questions. Del dot del cross A is equal to dou AX by dou X plus dou AY by dou Y plus dou AZ by dou Z. This is our del, right? Then del cross A. What is del cross A? Curl of vector A. Let's go to the definition. Curl of the vector A. Here it is in Cartesian. Del cross F in Cartesian. Curl. Okay, this is our curl. Curl of a vector. It is unit vector AX bar, AY bar, AZ bar. Then the dou, that is partial product. Dou by dou X, dou by dou Y, dou by dou Z. Then our vector Fx, Fy, Fz. This is in Cartesian. Del cross F bar. Let us use this formula here in solving our example. That is, this into del cross A is unit vector Ax, Ay, Az. Then partial product dou by dou X, dou by dou Y, dou by dou Z derivatives. Then we are having the vector, given vector Ax, Ay and Az components, right? So this into this. It is a dot product here, okay? Because here in between there is a dot. Am I right? So that dot you should not forget it. There is a dot in between. Del dot del cross A. It's a dot product between this and this. Okay. That is further equal to dou AX by dou X plus dou AY by dou Y plus dou AZ by dou Z dot of dot product of. Now how will you evaluate this determinant, students? This row will go and this column will go. So it is AX multiplied by dou AZ by dou Y minus of AY into this, that is minus dou AY by dou Z. Fine. Then when we come to in between term here, this we will take it, we have to take it as minus AY. This row will go, this column will go. It is dou AZ by dou X, dou by dou X into AZ minus of dou by dou Z into AX. Correct? It is dou AZ by dou X minus dou X by dou Z into AY. Then last term plus AZ, it is plus component plus AZ. The first row will go and the last column will go. Okay, so this row and this column will go, and we have dou AY by dou X, dou into by dou X into AY. That is dou AY by dou X minus of dou by dou Y into X. That is dou AX by dou Y into AZ. Okay, note it down up till here, students. Did you take down up till here?
No, sir.
Okay, fine. Then how to simplify this further? This is, we have got our X component here. Ax term is this, Y component is this, and Z component is this. Okay. Next, when you're dotting with this, okay, the first what we are having, that is a del operator. When you're dotting with the second term, okay, how to dot it? Ax with Ax, okay, then Ay with Ay component, Az with Az component. It is not like your normal multiplication. First term multiplied by first, then first into second, first into third. Not like that. Don't do like that. It's a dot product, remember. Now, whenever you're taking the dot product, how you have to multiply? Ax component with Ax component. Then plus Ay component with Ay component. You have to dot them. Az component dotted with Az component of the second term. First term Az component dotted with the second term second term Az component. Like this you have to dot them. Okay, it's not like your normal multiplication, remember this. Then if you are dotting here, then dou Ax by dou X, this is in my dotted with Ax, so Ax into Ax is 1. We know that vector unit vector dotted with itself will be equal to 1 always. Ax dot Ax is 1, Ay dot Ay is 1, and Az bar dot Az bar is 1. Hence we are having dou by dou X of dou Az by dou Y minus dou Ay by dou Z. Let us write it. Dou by dou X of dou Az by dou Y, note down, students, minus dou Ay by dou Z. Dou by dou X of dou Az by dou Y minus dou Ay by dou Z minus next one, because it is minus here, plus dou Ay by dou Y, then dotted with minus of dou Az by dou X minus dou X by dou Z into Ay. Ay dot Ay will be 1. Ay dot Ay will be 1. It is dou by dou Y of minus, it is plus into minus is minus, minus of dou by dou Y of dou Az by dou X minus dou Ax by dou z. I have written it here, minus dou by dou y of dou az by dou x minus dou ax by dou z. Clear here? Then plus next term plus, we are dotting the z component. Az dot az is 1, is dou by dou z of dou ay by dou x minus dou ax by dou y. The same thing I have written here, plus dou by dou z of dou ay by dou x minus dou ax by dou y. Is it not? Next we have to simplify this further. Note it down up till here, students. I hope everyone have noted down up till here. Yes, everyone have noted down up till here? Yes, students.
Wait, sir.
Okay, note down.
1 minute.
Okay, note down. Is it noted down, students?
Yes, sir.
Fine. Look here, dou by dou x of dou az by dou y. So this is dou into dou, that is dou square az divided by dou x dou y. Then plus into minus is minus dou by dou x of dou ay by dou z. It is dou into dou is dou square ay divided by dou x dou z. Then minus dou by dou y of dou az by dou x. It is again dou square az by dou y dou x. Minus into minus is plus dou square ax divided by dou y dou z. Then plus dou into dou square ay divided by dou z dou x, dou square ay by dou z dou x, plus into minus dou square ax by dou z dou y, dou square ax divided by dou z dou y. Is it not? Next we have to do the further simplification. What is simplification? We know that the derivative dou square az by dou x dou y is same as dou square az by dou y dou x. That is denominator, if I change the denominator, okay, that is dx if I change to dy and dy if I change to dx, then the derivative remains the same. It is the same derivative. Dou square az by dou x dou y, we'll get the same derivative when we derivate it, dou square az by dou y dou x, and so on. Hence, what we'll get here, dou square az by dou x dou y, this will get cancelled with minus dou square az divided by dou y dou x. Your mathematics. Okay, so these two will get cancelled out. Is it not? Then next, minus dou square ay by dou x dou z, then plus dou square ay by dou z dou x. Just there is an interchange of the terms dou x and dou z. It is the same derivative. Minus dou square ay by dou x dou z and plus dou square ay by dou z dou x. These two will get cancelled. Then last one, here I have put in the square the bracket square the box, plus dou square ax by dou y dou z, then minus dou square ax by dou z dou y. Okay, there is an interchange between dou y and dou z. It's the same derivative, hence these two will get cancelled. All the terms are getting cancelled, hence what will be the answer? Answer will be
0.
0. Answer will be 0. Okay, then what we have proved here, we have proved that del dot del cross A is equal to 0. Del dot del cross A is equal to 0. That is, divergence of the curl of the vector is equal to 0. Divergence of the curl of any vector field is 0. Okay, like this we have to prove this statement. Okay, this is one of the examples. Have you all noted down here, students, in the next part? If you have noted down, then we'll move to the next one. This portion, have you all noted down here?
Yes, sir.
Okay, then we'll move on to the third example. Okay, right. Determine the curl of the vector field. Here they have given the vector field. Given vector is p bar is equal to, or p is equal to x square yz ax plus xz az. The given vector is p is equal to x square yz ax plus xz az. Okay. What they are asking here, curl of the vector. What is curl of the vector? What is curl of the vector? What is, according to our definition, what is the formula? Del, whether it's del dot A or del cross A.
Del dot is.
Del dot A is divergence. Remember always, del dot A is divergence. Del cross A is curl. Remember always, when you are solving the problem, this is very important. You have to remember the formulas. Del dot A is divergence. Del cross A is curl. Del dot of any vector is divergence. Del cross of any vector is curl. Okay. Therefore, let us find the curl of this vector, that is del cross of p. Given vector is p here. That is given by, we have use this formula when solving the previous example. Okay, that is determinant ax, ay, az, dou by dou x, dou by dou y, dou by dou z, and the given vector px, py, and pz components. Okay, this is our formula for the curl of any vector in Cartesian system, students. This is in our Cartesian system. That is ax. Okay, so first row will go, first column will go, then dou pz by dou y minus dou py by dou z. Okay, then this is minus, the second term is always minus, we are taking when solving the determinant, minus ay into this row will go and this column will go, hence we will get dou pz by dou x minus dou px by dou z. The last term plus, it is plus az. This row will go, this column will go. It is dou py by dou x minus dou px by dou y. Is it not? That is, we are getting these three terms now. Next, we have to substitute the x component of p, y component, and z component of p and simplify further. That is, ax is equal to, I hope you all are noting down, students, here. You are noting down the example as I'm explaining here. Okay, very good. Therefore, ax multiplied by dou y of pz. What is the z component of this given vector p? Can anybody tell me? Z component of the given vector p is what?
Xz, sir.
Xz. Excellent. It is xz. Substitute that. It is xz minus dou by dou z of py. Y component. Who will tell me y component of given vector p? Yes.
0, sir.
Yeah, nice.
0.
Nice. Yes, it is nice. Correct. So it is 0. Okay. Py is 0. So substitute that. Minus ay of dou by dou x of pz. Z component is again xz minus dou by dou z of px. X component is x square yz. Yes or no? X component is x square yz. Substitute that, x square yz, and plus az of dou by dou x of py. Y component is 0 minus dou by dou y of px. X component is again x square yz. Okay. Next, we have to find the derivative. Okay. Dou by dou y of xz. There is no y component. It is 0. Dou by dou z of 0 is 0. It is ax multiplied by 0 minus 0. Ax multiplied by 0 minus 0 minus ay. Dou by dou x of xz. What is the derivative of xz, students, with respect to x? Yes.
Z, sir.
What is the derivative? It is
Z.
Z. Okay. So it is z, right? X, because x we are derivating with respect to x, so z is outside, so it is z minus of okay, this is our y component, minus ay into this is z we are getting here, then minus dou by dou z of x square yz. If we derivate, take the derivative of x square yz with respect to z. Okay, we are derivating with respect to z. X square y will take it outside. Derivative of z with respect to z is 1. It is minus x square y, minus x square y plus az. Then dou by dou x of 0 is 0 Then derivative of x square yz with respect to y. It is how much? Derivative of x square yz with respect to y. X square z you take it outside, it is constant. Then take the derivative of y with respect to y, it is 1. Therefore, it will be minus x square z. X square z we are taking outside, it is constant. Derivative of y with respect to y is 1. It will be simply minus x square z. Correct? Note down these steps, students. Note down these steps if you have not noted down. Quickly note down the steps.
Sir, last step can once again explain it.
Sure, sure. See, now this is ax. Dou pz by dou y. Ax into this is this step is clear. First step is clear. What all terms we are getting here? This step is clear.
Yes, sir.
Okay. So it is that is further equal to ax. This is our ax multiplied by dou pz by dou y. What is z component of p here? This is x component multiplied by ax plus y component is 0 plus z component multiplied by unit vector az. Correct? Now we have to substitute the x component, y component, z component in this whatever step we have got. Okay, that is ax multiplied by dou y of pz. Z component is xz. Correct? Xz is the z component of the unit vector or the given vector p with respect to the unit vector az. Magnitude is xz, direction is magnitude is xz, direction is az. Correct? That is substitute the magnitude xz minus dou by dou z of py. Y, there is no y component here. Is there any ay term here in this equation? Unit vector ay is there?
No, sir.
No. Ay unit vector is not there. Therefore, it is y component is 0. Y component is 0. Substitute that dou by dou z of 0. Then minus ay of dou by dou x of pz. Pz. Z component again it is xz. Substitute that minus dou by dou z of px. X component of p. What is the x component of p here? It is x square yz into ax. Magnitude is x square yz. Unit vector is ax. Correct? That is the x component of the given vector p is x square yz. X square yz. Put that. So it is x square yz here. Then plus az dou by dou x of py. Y component is 0 because there is no y term here. Ay term is not there. Right? Then minus dou by dou y of px. Again the same thing. X component is x square yz. Then we have to take the derivative. We have to take the derivative. Take the derivation of, if we take the derivation of xz, if we derivate xz with respect to dy, what will be our derivative? Here there is no y term in this. Correct? Xz, there is no y term. Therefore, it's a constant. Derivative of a constant is what? What is the derivative of the constant?
Zero,
Anyone?
sir.
0.
Zero.
Therefore, it is 0. Yes. You all are right. It is 0. So it is ax into 0 minus dou by dou z of 0 is 0 only minus ay of then derivative of xz with respect to x. Derivative of xz with respect to x. Z is constant, take it outside. Then derivative of x with respect to x is 1. Therefore, it is z ay of z minus dou by dou z of x square yz. X square yz. You are derivating with respect to z. Okay. X square yz you are derivating with respect to z. That means x square y is constant. Okay. Take it outside. Derivative of z with respect to z is 1. Therefore, it will be simply minus x square y. Okay. Then plus az of dou by dou x of 0 is 0 minus dou by dou y of x square yz. You are derivating x square yz with respect to y. Okay, that means other terms will be constant. X square z will be constant. Derivative of y with respect to y is 1. Therefore, it will be simply minus x square z. Minus x square z. Okay. I hope you are understood here. Everyone have understood up till this step? Still any difficulty? Students, is your doubt clear up till here? Is it understood?
Yes, sir.
Okay. So ax into 0 minus 0, it is 0 only, x component will be 0. Then y component, what we'll get here? Minus ay of z minus x square y will be our y component, and z component will be minus x square z. That is our next step. That is minus ay into z minus x square y minus az into x square z. X component is 0. This ay I will rearrange. I will take this minus inside. I will multiply minus 1 inside the bracket. Minus 1 into 1 is minus z. So it is minus z. Minus into minus is plus. It will be plus x square y. Okay. Then minus az into x square z. Minus az into x square z. Therefore, we'll get x square y minus z into ay minus x square z into az. Our x component is 0. Y component is x square y minus z, and z component is minus x square z. Students, it is not simply x square z, it is minus x square z. Note down z component of the that is curl of the vector. Okay. What we have done here, students, we have found out the curl of the vector, that is del cross p. So what is del cross p? Cross product is always, it is a vector, is it not? Cross product is a vector, dot product is always a scalar. Okay, the previous example that we have solved, we got the del dot a or whatever it is, del dot f, divergence, we have got it as a magnitude, that is a scalar quantity. Here we have taken the curl. The curl of any vector, right, it is always a vector quantity because it involves the cross product. It involves the cross product. Okay, hence it is a vector quantity. Curl is always a vector quantity. Okay, it has both the magnitude as well as the directions, unit vectors, ax, ay, and az. Okay, I hope this example is clear, students, to everyone. Any difficulty here? Yes, please.
Understood, sir.
Okay, fine. Let us move on to the next topic, divergence of a vector and divergence theorem. This is one of the important theorems. Many times it will be asked in the examination. It has been asked in the examination. It's a repeated question. Divergence theorem, one of the important topics. Okay. In the last class, I discussed what is a divergence of a vector. Okay, I gave the example of the tire tube, the cycle tire tube. If you open the valve, if you loosen the valve, the air will flow outside in all the directions. It will diverge, it will spread out in all the directions. Okay, and hence I also gave the example of the balloon. If you pierce a balloon or if you open the balloon, then the air will blow out in all the directions and its volume becomes 0 at the end. Okay, all the air will get diverged out, spread out outside, and then its volume becomes 0 at the end. Its volume shrinks to 0. Hence, we define divergence as, I have already defined in the previous class. Again, I am defining divergence of the given vector A is defined as the outward flow of flux per unit volume. It is defined as the outward flow of flux in all the directions, net outward flow of flux per unit volume, because the volume shrinks to 0 at the end. We are taking it per unit volume over the closed surface, over the closed incremental surface, small surface. That's why when writing the formula, we are writing it as follows. Divergence of A is del dot A. Del dot A is the divergence. Just now we solved the example. That is the net outward flow of flux or the flux per unit volume. What is the formula for flux, students? How we are getting the flux formula? If we integrate the given vector with respect to the surface over the closed surface, okay, the closed surface integral of the given vector with respect to the surface. Okay, what is the formula for flux? The closed surface integral. Remember, if it is a closed volume, then it is the closed surface integral of the given vector with respect to the surface, that gives the flux. This formula we have dealt in our previous session. Here it is. Here phi is equal to, when we are discussing about the surface integral. Okay, the phi is equal to close the surface integral of the given vector with respect to the surface. That gives the value of the flux phi. Okay, this represents net outward flux of vector field F bar from the surface S. That is outward flow of flux per unit volume divided by delta V. Okay, per unit volume divided by delta V over a closed incremental surface. That is, finally delta V tends to 0 because the volume shrinks to 0. The balloon will shrink to its original shape. Okay, when you blow the air, it will blow out and it will take the shape of a sphere. Okay, when the air is blown out of the balloon, what will happen? All the air will flow out and the volume will finally become 0. That example I have quoted in the previous session. Okay, that is limit as delta V, the volume tends to 0. This is our divergence of the given vector, and this is the statement of the divergence theorem. Remember, okay, this is the statement of the divergence theorem. This is our definition. Divergence of A is net outward flow of flux per unit volume over a closed incremental surface, and this is the statement definition, and this is our statement in the mathematical form. That is, divergence of A is del dot A is equal to limit of the closed surface integral of the given vector with respect to the incremental surface, a small surface ds, per unit volume delta V as the limit as, or the volume tends to 0. Delta V tends to 0. Okay. I hope everyone have understood the statement of the divergence theorem. Any difficulty here in the divergence theorem statement? Yes, please. I hope everyone have understood the statement. Yes. This surface, how we are getting this here? Look here, this f dot ds. This is our surface. I give the example of this surface, right? And we are integrating the closed surface with respect to this small surface ds. Okay, then we'll get the total flux that is coming out from the surface. Correct? If you are taking a closed surface, then it will be closed surface integral. If you are taking a normal surface, it is just the normal integral. Are you getting the difference? Okay, that is how we are getting this formula here. It is phi is equal to close the surface integral of the given vector f with respect to the surface ds. That will give us the value of the net flux or the total flux. Okay, is it understood, students? Here, students, did you all understand here? Yes, please, students.
Yes, sir.
Yes, sir.
Fine. Okay. In the next class, students, I'll be explaining the divergence theorem. I will let you know when will be the next class. The divergence theorem. Okay, we have to derive this. There is a derivation on the divergence theorem. Okay, we'll derive this divergence theorem, and then I will continue with the other topics. In today's class, students, I have discussed examples on finding the divergence at the given point. Then we have solved one example on divergence of the curl of the given vector is 0. We have proved that the divergence of the curl of any vector is 0. Then the third state one we have solved is curl of the vector. Curl of the vector field. Okay, we have solved this and we have found the curl of the vector, and we have seen that the curl of any vector is always a vector quantity only. Divergence is a scalar quantity, curl is a vector quantity. Then we have stated the divergence theorem. Divergence of A is defined as the net outward flow of flux per unit volume over a closed incremental surface. Mathematically, it is defined as divergence of A is equal to del dot A, that is limit as closed surface integral A dot ds divided by delta V, limit as delta V tends to 0. Okay. Any difficulty here, students, in today's discussion? Yes, please. Any questions? Any difficulty, students? I hope everyone understood the today's discussion, students. Srishal?
Yes, sir.
Good. Srishal?
Yes, sir.
Any difficulty in today's class, Srishal?
No, sir.
Okay. Vishal Vasulkar?
No, sir. Understood.
Understood today's topics, Vishal?
Yes, sir.
Okay. Sania? Sania? Okay. Harsh Loda?
Yes, sir.
Understood, sir.
Okay, good.
Understood, sir.
Okay, fine. Virpaksh Loda?
Sir, understood.
Understood? Okay, good.
Yes, sir.
Then we'll
Yes.
continue in the next class. Yeah, okay, fine. Thank you. We'll continue in the next class, students, with the definition of divergence theorem, and then we'll continue in the other topics. Okay. Thank you.
Hello, sir.